Hi there. Today we're going to talk about sound generation routines using 6502 assembly in the Apple II. So the Apple II does not really have a soundboard. You don't have any hardware routines to deal with pitch or with voicings or any of these things. It really just had a speaker and some routines to make the speaker click, and then you need to make the speaker click a certain number of times per second to get the frequency of the pitch that you want. In this way we could make crude notes and musical effects and sound effects in general. So it's very, we are working with very limited resources, but that's part of what makes it interesting. So let's dive into it. And we start with a sound generation routine that really just makes one single click with the speaker. So let's see that in action. We assemble this program. And what we are doing here, we are simply loading the accumulator with the value of memory address C030. This memory address is the speaker address, so we label it properly here. And it really doesn't matter whether we load or store there, because there's no value to be read at all. It's just when you somehow touch that memory address, you provoke a click. So let's, I'm gonna execute this, and probably I'll have to execute it a number of times because this click is very soft. So let's try to hear it. You see, it's really like a very faint click. So that's a single click. Of course, that doesn't take us long. So let me paste here a slightly variation of this program. So here we are starting at a certain memory address. We're calling it pitch because depending on what we put in here, we can change the frequency. So we are loading the Y register with the values of this memory address, and then we are clicking, and then we have a loop here where we basically keep from the value contained by this memory address, we keep decreasing it until we reach 0. And then this is an infinite loop, right? Because when we are done with this delay loop, right, the one that will basically give you a pause between each click, we jump back to the beginning. So this is, when we run this program, it's going to cause a certain pitch to be played continuously. So let's assemble and see what happens. Yeah, you can see, I'm gonna pause here. You can see that we can hear the pitch. Okay, now that we know how to produce a sound of a certain pitch, let's look into an even more complete example where we not only play a sound of a certain pitch, but we do that for a certain duration. So we have a new address here that stores the duration, and then we start by loading this value on the X register, and then we have the same loop that we had before, right? We load the value of pitch into the Y register, and then we make a click, and then we decrement Y, and then we keep doing that until it's 0. But after we do that, now we decrement X, which has the value of the address duration, and we decrement it until it reaches 0, and then we basically go back to the loop again. So let's run this and see what happens. You see, now we played our sound with a certain pitch for a certain duration. Which takes us to a final example. In this final example, we are going to use the keyboard as a means to change the pitch. So we get, perhaps calling it a piano is a strong expression, but we get something that has keys and we can change the pitch depending on the key that we press. So we are already familiar with how we read a keyboard and how we clear the last key read using the strobe. And here we use the speaker again. So what we do here is we basically we load the value of the last key read into the accumulator. And then we just touch the strobe content to clean the last pressed key. We check if this key is above 80, and if we have touched any key, it will be above 80. Otherwise, if we press control something, for instance, it's going to be below, and then it's going to exit. Because we're running this in a browser and not in a real Apple II computer, actually the control keys trigger the web browser's shortcut, so this is not really working as expected. But in the Apple II computer, you could expect that if you press, for instance, Control Shift P or Control at something like this, you could basically you would exit the program. In our case, we're gonna just stop just reboot our virtual computer. So again, we put the last key on the accumulator, and here what we do is we transfer the accumulator to the Y register. Then we produce the click, then we decrease the Y register, and we keep doing that until we reach 0. And then when we reach 0, we jump back to entry, and we do that again. We try to read another key. So what this is going to do is, depending on the value of the key that we press, if it's a higher value, we're going to spend more time in this delay. And if the key has a smaller value, then we're going to spend less time on this delay routine, and that is going to give us a different pitch depending on the key that we press. So let's see that in action now. So I'm gonna stop this annoying sound. Sorry, but now you get the idea. So I was pressing different keys on the keyboard, and that was basically changing the delay, and by changing the delay, changing the frequency of the clicks, and changing the pitch accordingly. You can see how we could, I mean, if we kept exploring this theme, we could get to get this really to play music with pitches and pauses, and or that you could create like a virtual piano on the keyboard, that depending on the key that you press, you play a certain pitch for a certain duration. So this is an extremely simple example, and of course it's not yet very practical, but it's an introduction to the topic of how we generate sound in the Apple II using assembly. So I hope you enjoyed this video, and see you in the next episode.